good, great to be here. So bringing Hypermedia to the masses, I see that I managed to gather a small mass, I suppose. Okay, what's this again? So the title is slightly catchy, a bit of a clickbait or well, sit bait, because I haven't yet had a chance to really bring it to a large mass. So hopefully you increase that that crowd by a significant amount. So my name is Tomasz Pluskiewicz. Usually just Tom. So if you feel afraid of speaking to him because you don't know how to pronounce my name, Tom works. I work for a small consultancy from Switzerland called Zazuko, where we do linked open data for a bunch of Swiss national government agencies, also municipalities, mostly. So linked open data, that is a set of technologies around semantic web, which I've been a long-standing fan, which is a bit of a, well, subject that not everyone is familiar with, but revolves around data which is being published on the web, consumable by everyone, which somehow brought me through the back door to REST APIs. So with the semantic web, everything is on the web. It's all URIs, all dereferenceable. So that's how I discovered REST APIs. And then those two combined brought me into Hydra community group, which I've been a long contributor. That's a W3C group which tries to bring Hypermedia, Hydra being a media type, to describe APIs using the semantic web technologies. So even though it is going to be part of the presentation, as in all the examples, the code, Hydra is the tool that I use, but I hope that I can convey some ideas which are agnostic of the media type and technologies, but rather just give you an overview of how I think APIs can be built and consumed by the clients. So as Bill mentioned, I have this year organized RESTfest in Poland, but RESTfest itself, it's been running for 9 years in the US, in South Carolina. As you see, this year we've had 3 events, all of them already behind us. So if you're interested in speaking at a small conference, small unconference actually, where we are very intimate, everyone speaks to everyone, we share ideas, then watch restfest.org, watch the Twitter. As a reminder, you might be interested in some t-shirts in that daring yellow color. Just be careful, don't use them, don't wear them in summer because insects love them. So for today, that's what I have planned. First, I will just give you an overlook of what I think about how web applications have been built traditionally. Let's call that, especially single-page applications. So that's what I will be showing then as an example of a Hypermedia-driven front-end application consuming a Hydra API. So a bit of demos, a bit of code. We'll see how that goes. Also, feel free to interrupt at any time. I suppose we have plenty of time, so just feel free. And then finally, slightly unrelated, I will show you my latest development around testing APIs. So maybe not exactly related to the consumer end, but completing a full story of building and consuming as an API that has to be robust and well tested. So then questions probably has a place on the agenda because we'll see how much time we have, but it is meant to be a question session, right? So I've started thinking about how APIs are built and consumed somewhere in 2016. I mean, deeply about the front end of the story, and I have been slightly unhappy with the state. So the APIs, my experience with APIs that I built, that I consumed, is that they didn't really provide a solid foundation for the consumer. So the worst case scenario is that it's just plain JSONs. the resources are not linked to the other resources. The client does not have any information at runtime that it can follow, that it can take advantage of to really run the application. So we end up with a UI full of outside knowledge, so written documentation which developers read before running the application, and all kinds of tribal knowledge. So as an example, I say routing in single-page applications. So typically what it is like, we have a URL that's just a bunch of segments, some of which are placeholders for variables. That's the browser URL. So we extract those placeholders, and then we somehow reconstruct identifier for what we call on the API. But that forces assumptions about the resources, the representations, that are sometimes untrue. And even if we don't speak about the unexpected. So for example, there was a presentation yesterday about problems. So for example, you may have a /order /some number resource. And being humans, we kind of understand that what we get back is an order. But the representation may be slightly different depending on the permissions of the caller, the state of the resource, or maybe if there's actually a failure, it will return something completely different, like the problem plus JSON error message. And traditionally, if we assume that what we get is an order, then the application becomes, well, either breaks at the unexpected, or requires a lot of coding on the front end. So we just get a bunch of if statements and all kinds of conditional logic which has to adapt to the unexpected on the API. And of course, because the APIs, there's little APIs that have really given all of that information at runtime to the clients, we ended up with all kinds of harmful patterns. So code generation, SOAP, but then anything like the even Open API, where we have a static API description, which is then used to generate code. As soon as this description changes, the client potentially breaks, unless the code is regenerated. So that's not really robust. That's not something that promotes evolution of such API. And going further, API is not just a single request and a single response. We have entire workflows, interactions between multiple resources, and entire stories that the client follows to achieve some end result. And then, without additional information at runtime again, the applications have to be somehow built around the assumptions that, okay, I got one representation, and then I assume that what I can do is then another request and another request. And again, any deviation from that will likely break or require additional coding. And finally, the probably first sin that everyone building APIs makes is relying on the specific URL structures. Like I said, with routing, this prevents, first of all, it is tight coupling to an implementation detail. The client should not care about the actual URL of the resource, and then prevents the server from actually ever changing those resources if clients rely on them. So the implementation detail becomes a blocker for evolution. So either the server doesn't care about its clients and just changes it, and the clients have to be updated, or the clients just break, which is, in the case of public APIs, will be a tragedy, right? Now, I'm pretty sure that we can do better. We have potentially all the knowledge, all the tools, well, not the tools just yet, but the mental picture of improvement to what we do, how we build APIs, and then how we consume them. So, excuse me. Let me give you an example of how we can shift the mindset a little bit. So that would be an hypothetical registration form, like you've seen many times. So a bunch of text fields, maybe, so name, some of my, what do I like, so interests, usually there's a birthday, that sort of thing. And then at the end, there's usually one or more checkboxes. So usually one of them is required, being some kind of accepting the rules, conditions, terms, conditions, whatever. But sometimes there's more, like newsletter, which most of us will not like to tick. So what happens if I forgot to check this box? You tell me, what usually happens with the client application? Well, of course, it may just fail, may just give you an answer that, yeah, well, you didn't tick the required box to go back. But typically, the application tries to be nicer, and it somehow gives you a visual hint that, yeah, well, you have to actually check this. And it happened to me just once, and I'm really surprised that I've never really observed this again, that instead of this happened. So I forgot, I did not check a checkbox. I think if I recall correctly, I'm not sure what application that was, some kind of forum or whatnot. I think I mistook this checkbox for an optional newsletter acceptance. I clicked register, and instead of some kind of failed response, even if this is not really implemented using Hypermedia as the request response on HTTP level, I got actually redirected to the full text of the terms and conditions with an option to decline or accept. So curious, I went back, and then I did tick the box that was required, and then click and register. I went straight for the success, whatever, confirmation page. So the logic here branches, and I mean, it's a revelation. It was something really so surprising to me, because this is how application can be built, yet they aren't. So the medium that we can, the driver that we can use to actually build such application in that manner is Hypermedia. And so I've identified 3 areas of those. So what I have been mentioning, in principle, that need to change in order to really build an application in that way, that go hand in hand. So first of all, the routing. Again, I am speaking solely about web applications, so that does not apply to thick clients on mobile phones, maybe. Then, of course, we need the actual medium, so the media type that will convey the additional information for the clients to use. And finally, the way that we build the actual user interface must change slightly. So let me first, this is an example of the routing, or quote-unquote routing. So that's a URL of an actual application that I've been building, and I will be showing you later on screenshots and running. So for me, the routing is not really, is just a direct one-to-one relation. So when I get a URL like this in the browser, it translates to a single URL on the API. So of course, I decompose this by of course looking at discarding the base. So that's the application, so a bunch of static JavaScript and HTML files from whatever static server, CDN or whatever. Then a single application may not be served by a single API. So I simply replace the first segment here with the base URL of the API that's running my application. So in my case, currently I just have the library in the home, but I will have a bunch more microservices, so separate APIs, if you will. And the rest is just taken verbatim. This is simply the absolute path on my API. So whenever I request open in the browser on that page or refresh, it will get the brochure /1300 on the API mapped from the library segment. Simple as that. So there's no hacking URLs, there's nothing. If the server changes those URLs, the application does occur, it will just change, it will automatically change on the browser. So the user doesn't know. Of course, bookmarked links break, but otherwise, whenever a user starts from the home page, from the root of an API, it will not notice any difference. And of course, that part is completely unrelated to how the server operates. It's just telling the application where to fetch its data. And once we get that data, like I said, we need a media type that will be rich with links and other information on what the client actually got. So this is where Hydra comes in, but there's a bunch of alternatives. Like I think one of the more popular would be Siren by Kevin Swibert. But Hydra, like I said, my thing, because it's based in JSON-LD, which is an RDF format that stands for Resource Description Framework. So it's a bit verbose language, full of URLs, which, well, describes resources on the web and how they're linked and also their meaning. So it is a web-first design. It assumes that everything is on the web, and most of it will be actually reachable with HTTP protocol. So Hydra is still a work in progress, but it might be the most promising media type because of its extensibility and routing in W3C standards. So JSON-LD, RDF, all of that are standard. They're not going to change, at least not in a breaking way. So let me just briefly, this will be a bit heavy for some of you, but let me just quickly show you, is that also a pointer? Okay. What a resource representation looks like in Hydra. So it is JSON-LD in that snippet. So the add context is a resource which, or it can also be an object inlined here, of course wouldn't fit in the slide, which describes the meaning of the keys and values of that resource. Then of course the add ID is the identifier of the resource, so it's URL. The add type simply tells the client what kind of content we expect here, and then it is just standard JSON nested with more resources. So you see, this particular is a book with a title with an ISBN number. Those are schema.org prefix values. So it reuses common vocabularies, does not reinvent new terms for the titles, so that they can be understood by anyone who understands schema. And then similarly, Hydra here prefixes the media type vocabulary, and an operation tells the client that, okay, this resource can be updated, again, schema, by sending a put request with a book representation, so a book similar to this one. So to understand what the book is, Hydra links from every resource served from Hydra API, links with a HTTP header to another JSON-LD document, which describes the entire API. So it is a bit like an open API description, but it is discovered at runtime. It can be cached, but it is also by nature dynamic. So it can change. If we log in, we can get a bit of a different API documentation. So the book would be described, so that of course an excerpt, will be described that it's a known supported class of book. It has an ISBN property. It has another property, didn't show it in the other slide, called author, which also is a Hydra link. That's an important hint because, like I said, everything with Hydra, with JSON-LD, will be essentially URLs. So Hydra points at specific links, much like a tag, the anchor tag of HTML, to give the client clear hint that this is something that you might be interested in actually following and getting that representation in turn. And finally, Hydra has a bit of additional building blocks, most notably a collection. So quite a simple concept. So the type here is Hydra collection, which this is a very contested structure, but it essentially says that the type of the members will books. So it's kind of like a generic collection if your language does that. So this collection will contain books. It also has a search link, which is actually a template, not a concrete link. So there would be additional information right here telling the client how to construct this URL with the page title, author, and language variables. So the essentially builds a form fills in the user or another application fills in this URL, and that's the resource that you want to fetch to filter or page through the collection. And so if we combine all of what I said about the media type, so about Hydra, but also about schema, for example, I've realized this not long ago, but I looked at some other opinions. So of course, looking it up on Google quickly confirmed that there's other people at least that think similarly. That I made a mistake before of thinking about the uniform interface REST constraint as being purely about HTTP. So HTTP methods, HTTP headers, basically the protocol being the uniform interface. But to actually build an application that clients really understand, we need a bit more. So we need the media type. So of course, an application is speaking Hydra. Hydra itself, its processing algorithms and its contents becomes part of the uniform interface. So any client that understands Hydra will uniformly know how to operate with it, how to interpret what it tells them. But we also then get into application-specific details, such as vocabularies used. If I use schema title across my resources, then anyone requesting any of my resources, and also third-party clients, will understand the meaning of schema title. So that's also part of the uniform interface, I think, by definition. So let's, I'm sorry. That's the application that I'm actually building. So, of course, it has some parts which are completely static. There will be the same on every page. So there's a header, there is, you don't see it, there's a footer. So those parts are just there. I call them the shell. But then anything else, anything between the header and the footer is rendered, presented, differently depending on what we got as the resource representation. So in this case, this is a root resource of one API. So this right here, that's it's actually not schema title, but Hydra title. But again, part of my uniform interface. And then here, each one of those three sections is a representation of a Hydra link. Each one of them, again, having a Hydra title, a Hydra description. It's completely dynamic. The server gives all of that. For the client, it's just determining, okay, I kind of know what I got, so I know that I can put some kind of header and then the links right here. There will be more, just the APIs aren't there yet, but I'm working on that. So I mentioned the other one being the collection. So of course, something that will be a repeating pattern within an application. So that's my rendition of a Hydra collection from that API. So again, the previous and next page are known properties, next and previous, much like link relations that you would see on HTTP headers, but part of Hydra spec. Then the Hydra search is built dynamically from the template similar to what you've seen before. So in this case, the search, the collection can be searched with a title and a language. And then there will be some additional user interface the more I add to the application. And of course, the title up here, again, this is the same Hydra title they've seen before, only that because this is not recognized as a significant resource as the other one, so it's just a plain title. So the decision of what kind of title it is only baked into the application by looking at the resource representation. So that's a trivial example, but same goes for the individual pictures and the names under them here. This would be on different collections of different content, would be dynamically rendered based on the actual representations, the actual resources that the collection holds. Yes?
A question on the previous slide. The icons there for brochures, books, and magazines, are those provided by the API also?
No, they could be. In this case, they are essentially SVG, so they could definitely be linked as SVGs. Currently, they are determined by looking at known properties. So the link is obviously tells you of what nature it is. So what's supposed to be, what's expected to be on the other end of the link. And so if they none of those will match, then there is also a fallback icon that will just be displayed if anything else fails. I actually have that in code also. And finally, there is an individual item, which is slightly specialized. Of course, the title again. The schema image right here, so keeps reusing the known vocabularies for an image object. That's what it's called in the schema lingo. And then the rest here is just an iteration of all the other supported properties. So anything that's unexpected will be ignored. But then we know from the API documentation about these properties, we know their titles because API documentation also has those human-readable descriptions of the API. And the values are in fact not simply text, because for example the languages here would be an actual link to a language vocabulary. So the application is here coded that okay, when we find a language property, we know how to convert it into a human-readable form. So this is something application-specific in that regard. But it could also be trying to dereference if that's another resource from completely outside API. But of course, we then go into all kinds of performance problems if we start to fetch different stuff from APIs that we don't control. So to rehash this, the uniform interface promotes vocabulary reuse so that across an organization, such vocabularies can be reused so that teams building applications and APIs share a common denominator. Representation patterns. So you may have noticed that the title in a different form was something driven by the contents, but actually repeating on each page. And so is same for a page like this one, where I have this placeholder, but otherwise I would fill in and maybe add additional contents to that page as I expand my API and the information that it serves. But at some point, the entire application will be a set of visual frameworks. So that in this case, I have this middle, well, the left middle pane, and then the sidebar. The collection had the sidebar on the other end. So the application becomes a decision between a completely generic client, which knows nothing about the API and just tries to, in some human-readable form, present the contents, or we build a bespoke application which prepares this kind of layout for the different kinds of resources that we expect on that API. And finally, what I started calling Matryoshka UI. So Matryoshka being the Russian dolls, that you have the big doll, so that's the application shell, and then you have the smaller doll, which is one of the possible layouts with the links in the middle, or it's not there anymore, or the sidebar on either side, maybe something that you have specific in your application. And so the UI has to be built in that manner, that the large doll does not care what will be presented in the smaller doll. It just knows that there is a place for additional markup. And that's somewhat, the implementation detail here is a bit different. So I will show code in my IDE. It will be slightly different, but the actual idea is the same here. So the entire user interface, or most of it, is composed of essentially functions that return portions of HTML. So that's the very top of the application, and it knows that for the current state of the application, it passes the resource to another function, which essentially recursively calls is called by the library to determine how to interpret and what kind of will be the contents of that portion, identified just by a name. Then we have some div section static elements, and then just pass the rest to a main content placeholder. So that's something that is familiar to anyone working with CMS, where you have those bunch of placeholder sections, elements that are filled in with your data. So then it gets much more specific. So for the page title, when the resource is an entry point, so just a lingo for the root resource of an API, this is where the page title is, well, in this case, a web component. That's the one with the background of the image. Otherwise, it will be just a gray div. And yeah, and then the last piece of the puzzle for the user interface just becomes collecting the user interactions. And so there's no, I can show you in a moment on the live examples, and the code wouldn't fit the slide here, but essentially the forms can be and should be dynamically generated, either for generating additional requests, for the operations that you saw on the Hydra slide, so pretty much what a form does in HTML. And then, but similarly, the URL templates essentially also become forms that collect user input, are translated into a GET request. So I built this other library, similar to the one for the nesting, for the view nesting, which is completely, I want it completely agnostic of Hydra. So there are Hydra-specific extensions, where I simply give it the template with its description and renders the form. But otherwise, it can be used with any toolkit. It is completely agnostic, similar somewhat to Angular formally. That's one I'm familiar with. And it can be easily adapted to the given look and feel. So I have a demo with material design components, but for the case of my application, I just used the Bootstrap templates that came with the entire design system style as they should be. Okay, so that's the point where I can indeed show you some of it live. Okay. So this is answering the question. Sorry. The application, like I mentioned, is currently running on two APIs. One is simply just an API that points to the other APIs. I just didn't want to have a bunch of configuration variables. Instead, I have the home API, which links to the other one. And this is the fallback icon. I haven't specified how this should look for that API. So it is just this box thing. And then we'll have to wait a little bit. That runs on free Heroku, so probably starts up right now. I thought I warmed it up late enough, but I guess it went back to sleep. There you go. So this is precisely what we were looking at earlier. I can follow the brochures link. And there it is. Of course, individual pages are a bit bigger than what I had adapted for the slide. So the important thing here is, and it is something that I also ignored for a while when building different demos, technical demos earlier, that even though I followed the next page link, and you might have noticed that now I have page 2 in the browser, it actually displays the combined contents of the two pages. And when I keep adding more pages, it just adds what it found, the additional items. before it would just replace the previous elements with then the next portion. So, but if I refresh the entire page, the browser no longer has the information of the previous pages that have been loaded, so it will just load that the last page. So it just loads this bit, and now it has the previous and next links. And of course the titles, let's see. I can filter it for Scania, and then we get Swedish buses. So the important takeaway here is that that's really unfortunate. That the application actually persists an additional state. It's not just the single resource that got retrieved from the API. There is a larger state that the application maintains through its lifecycle of user interactions. So this is something that has to be planned. I don't have an opinion of how to implement it. It could be Redux, it could be Mobix, or whatever other pattern. I use something called meiosis, which is similar in principle, that there is a single object which I build and then propagate into the functions. And then just a single point of entry to modify that state. So it is something that I initially trivially ignored, just assuming that when I follow link, I just toss everything and the new representation is my state. But of course, that's not the case if you want to build performant and useful applications. So quickly, I'm looking at the codes. I said there is a shell, and of course, this one is not really reusable, so it's purposely built on top of specific design, styled and structured as it is. So the shell is a custom element that maintains the connection between the URL and the resource identifier, and makes, well, actually that's what it does. But it could, instead of using the HTML5 history API, it could do the hashes or completely ignore the browser so that refreshing always comes back to the starting point. Like I said, it defines some building blocks and then simply delegates the rest to the UI library I showed you earlier. So, for example, let's go straight for, well, no, let's actually start with here. So this is the exact snippet that you saw before. So the recursive call to the page title, to render the page title portion, and then the rest is in the main section. And it does then go deeper. Exactly the, let's see.
Is it possible to increase the font size?
Yeah, of course. Let's do presentation mode. Oh no, I hate when this happens. Good. That's good. Oh yeah, I remember, but now I never know how to go between the other pages. So now let's exit presentation, and let's just make this big. Oh, yeah, I know I should have closed. I mean, I always make that mistake. Anyone knows the commands? I always... Nah, it didn't work. There's something else. No, I want to increase the font. No. I guess it is somehow not bound. Let's do it like this. Tell me when to stop. Okay. Okay, I can pinch. So this is, for example, the part where the properties are rendered in the listing for the individual item. So if everything fails, it just takes the value and puts it there. So there's a risk of object because we're in JavaScript. When we find a name property, so that applies to an author. I probably will change this, but that's what it is for now. So when it's an author is actually an object with its name. So the name will be used, and then this is what it does for the languages. So a bit of hackery to really contradicts what I said, because I actually do hack the URI of that language identifier to get the ISO code and use a JavaScript library to get its native name. Similarly, here's what happens with the icons. So that's actually quite simple. With some syntax trickery, when I find the books property, it's an open book icon if it's a brochures property, and then as a fallback, it's just a box. Okay, and then the form. So the form is, well, extending from the base element. I haven't built a reusable element for the template just yet. So it maps what Hydra describes for the template, builds the media type agnostic description of that form, but then whenever I publish this as a reusable element, in the browser, all you see, and then anyone wishing to display a form for such template, it just becomes an element URL template form. All right, that's nice. Yeah. So it's let's see where it's used. URL like this. There. So again, it is being rendered using all the same principles. So when you find a collection, currently not yet as adaptive as I want it to be. For now, I just expect the search to be there. So for a collection sidebar, just put a template form there, looking for the search, Hydra search, and something on standard to so that when the page is reloaded, that's something that Hydra doesn't do well yet. We just want to put whatever was used to construct that URL back into the form. Otherwise, even though we open a filtered form, it would currently there's no way to describe that resource, saying that, yeah, well, this is how the URL got constructed. All that the client gets is the actual URL. So that's something I had to do non-standard, but hopefully we can put it as a piece of Hydra as well. Okay. So that pretty much concludes the codes part. So if there's any questions right on your mind, then go ahead. If not, let me just introduce you to the other part, which I said. Recently, I started building a DSL to run scenarios, run requests essentially over an Hypermedia API. So again, in principle, it is two DSLs. One which is a core DSL, which just defines some basic Hypermedia terms. So essentially links and properties. And there's also a flavor for Hydra. And it forces the scenarios to really follow the hypermedia controls themselves. So, of course, there is a bunch of testing tools, Karate, Rest Assured, or maybe Postman, where it is possible to build bigger scenarios of multiple requests, chains, so that we have an entire workflow, but they require the knowledge of implementation details. So the first request is a get, then we issue a put somewhere, and then another request, which, first of all, it is possible to build scenarios which will not occur on the client, because we also cut corners and just assume what is the correct order of such interactions. With this approach, the test scenario actually has to rely on the hypermedia controls being served by the client, by the server. So it would read like this. So we start from a single, we start from a single URL, and then the test expects that there is an employee class. Maybe it should say resource of type employee. That's a mental leap here. So you would see that from this representation, it would find, okay, we have an employee, a representation of an employee. So we want to check that there is a salary property, and then there's a link to a manager, and then follow that link also, dereference that link, and do some additional verifications on it. And then we look for a contract property. So in JSON-LD, unlike HAL and other, there's no special embedded construct. This is just JSON, which, like I said, can have nested representation of the linked resources. So we look for the contract property, and it should have a terminate contract operation. So it's not the test is not as simple as get an employee, get the contract, and terminate it. There would likely be a delete. Could be a delete request, but this scenario does not care if it's a delete, if it's a post, and it also will fail if it does not find that operation, because the behavior that is advertised by the API can be dynamic. Like I said before, it can change depending on the state of the employee, the state of the contract, or the permissions of the caller. So this way we not only test the behavior of individual requests, but actually the completeness of the full hypermedia chain, or I don't know how to really, there's a name. So I've been using this for my end-to-end tests, and I think it works. I know that not everyone is super happy. I had comments on how this is structured, but kind of limited by the toolkit. We built this with Eclipse Xtext, which, well, I'm not the biggest fan, but it seems like the best tool to build DSLs anyway. The only alternative is from JetBrains, and it seemed to have even bigger steeper learning curve, and that's what we ended up with. But still, I think it's quite useful. And finally, this is in turn Hydra specific. I built a website and a CLI tool for static analysis, kind of the API documentation itself, because there is a bunch of issues that can be easily determined. One that I don't have the exact check just yet, but for some reason, a given property, so now I'm going into a very specific detail, but there is a property which is called writable, which instructs that it can be modified on a request. And it is spelled differently than I usually would think, and I think it's spelled incorrectly. So I've made that mistake a bunch of times. It's something that can be checked. I run this, or rather the CLI tool, also on my CI for the APIs that I build. and gradually expanded, this will offer a first line of defense against potential mistakes, because again, this is not the API documentation that's being analyzed here is actually part of the API. So it's not simply linting a YAML document or whatever. So to summarize, what works and what doesn't. I think you saw what works, but I can now admit what doesn't work. So the first thing, the one battle that I will have to fight soon is that you saw the routing thing, which links a single state of the web application with a resource. But there are such views, pages in an application that are not necessarily linked to a single resource, or at least more importantly, composed from multiple. The one thing that I want to implement in our API is I want to gather all of those Hydra search endpoints, the templates, and have just a single search box at the top. And then when that's filled in and submitted, it will not actually make a request, but instead it will give links or maybe preliminary results of searching those different search endpoints. And that is not something that it is a resource in itself. And I think it would be a mistake to really make an artificial resource just to link to the templates. So I've not yet figured that one out. And what I said earlier, the state is not just the representations, or at least not a single representation. It's many representations over time as the user progresses through the application. One such example, which is, well, first trivial, obvious example is the navigational menu on the top. So that's something that is requested. It's also built dynamically from what the client gets from the APIs, but it doesn't change. At least currently, it doesn't change with the application. Although it would when there's a login feed form. The user having logged in may get additional options, additional links. So that's something to keep in mind, which may not be such big of an issue for people that have been building traditionally with whatever APIs they got. But like I said, I did have this simplified mindset. If there is Hypermedia, this is all I need. But it's a bit more complicated than that. Now, also one thing that's missing at this point, and I've had a number of people ask me about code on demand, because it seems quite obvious that you asked about the icons. Not strictly code on demand, but could be viewed as such, so that individual resources can offer offer ways for the client to even more dynamically build their markup, their content. But the problem I have here is that an API, unless it's really built with the sole purpose of serving a specific application, I view APIs as something being more open to unknown clients. And then if I build an application which is bespoke and it has the specific structure and the specific kind of markup and elements and styling that I use to really build a visually cohesive whole, then how do I have a universal API, a reusable API, serve specific code to build UI just for this single application? And then if the code on demand serves very generic markup, very generic visually elements, then it will just look ugly. So maybe the answer is simple. I would really like you to tell me, but I haven't yet figured that one out. So the ongoing work that I kind of stalled for now because I have been reworking the ground, the building blocks, the shell, those elements, and I'm intending to be documenting them on the building hypermedia.app, so that it is simple to just install elements from, install packages from NPM, the shell, set it up with your own API, set it up with a Hydra or other API-specific loader, as I call it, so that it uses, for me, it uses a Hydra client to fetch and then parse and get meaning of the hypermedia, and then pass it on to the view layer. So hopefully, for another application, I built a material design shell that I've already used a number of times, because it just offers the visual framework, and then I fill it in with API-specific design elements, which actually I can actually open and show you right here. So generic hypermedia app. This is what I said, and then in fact, because it consumes Hydra, I can actually run. So this is the same kind of shell, but with the different static elements. And it opens that same API that drives the other page with the link to the brochures, for example, which is a Hydra collection with the same form rendered using the same element, just made to look like material design. And I can also traverse it using the same hypermedia controls. So this has been quite useful, even though it's not really 100% complete, but it's been quite useful for test driving application APIs that we build that don't have a UI just yet. So it is kind of like a universal application for any Hydra API. Yeah, I can open one of them. So it doesn't understand the schema image, so it only shows some of the URLs that I can open to get the actual image, for example. There you go. So yeah, it seems like I'm just on time. There's some links to the actual tools, their respective GitHub or documentation demo pages. So that's the JavaScript components for the routing, the views and forms which build the visual elements, and the Hydra client. I haven't really spoken about much, but I think that would have been a bit of a stretch. So again, yeah, that's just repeating the other links. Okay, thank you.
Okay, thank you, Tomasz. We have time for Q&A. So I'm going to pass the mic around. I know it's a small room, but it'll help for the recording so everyone can know what the questions are. Yeah, anyone want to start?
I wanted to ask about the Hydra client that you used. You actually had the link at the last slide. But so this is the client which you use in the front-end app. Yeah. Do you know? Are there any? Do you know any other clients, or are there any clients for, like, also backend applications written Java or PHP or something like that? Are you familiar with that? So are there many tools, many clients for different
yes,
languages?
Not much, not many just yet. There is one other client for JavaScript, and then I know of two in the making for .NET. And I think there should be a client for PHP. There is this framework called APA Platform. So they have, they claim they have a complete Hydra implementation. So I'm not sure how they actually consume it. So if they have their own client, or if they may also rely on the JSON itself. So it is possible to just shape the JSON and make sense of it using just standard tooling for whatever language you use.
Yep.
So this seemed to work very well with this sort of the books, brochures, and magazines have the same structure, and you can perhaps change some properties. But what about using Hydra in, for instance, the Facebook web client, where you have groups, events, you can invite members, you can edit posts, and so on? There are quite complex operations which has a specific context, and it seems more difficult there to just let the backend decide what can be done, and the client should react to that. Can you comment on that?
Well, it is an open question, and still there's been a lot of discussion in the Hydra community group itself, because I think it would comes down to machine, where you have shared contracts, and then maybe separate APIs that somehow know how to connect the dots, connect their data with what the server expects, what another API expects. For the UI end, I would think that the Coda demand should help a little bit, but then with Facebook it could be very simple, avoiding the issue of without having to avoid the bespoke UI, because those APIs are only consumed by their own applications. So maybe individual APIs independently can provide their own UI, and the rest of the application only knows how to then provide the missing pieces.
Okay.
Yep. So what areas of Hydra are still being worked on? Is it that there's some areas not yet covered, or is some parts of it likely to change, do you reckon?
We will be avoiding breaking changes. I think the most sought after part is to replace the description of the forms, so the classes as presented before, with Shackle, which is another standard language for describing the. So it's Shackle stands for shape constraint language, so that it describes in detail what kinds of properties and how the object should look like. So essentially a validation tool. So that would allow for a more rich description of the interactions. Otherwise, I would say it is fairly complete with some missing pieces here and there, but I think that most of the implementers just fill in their blanks themselves, like I did with the template. And the problem is that they don't often share back. So there are solutions, but maybe we just don't know about them. And then standardizing is another matter completely, because this is the community group, so we strive for consensus, and it really slows down the progress.
Any other questions right now? Okay, well, we'll have the video on YouTube in a week or so you can dive more in depth into Hydra, and obviously so much that the community is working on is online. So yeah, let's just call it there. Thank you.
Thank you.